So in this question, you have identical point charges placed on the vertices of a cube of edge length A. So I've already drawn that diagram. You have 8 charged particles Q placed on the vertices of a cube of edge A. And it's mentioned that now each of them experiences a net force of magnitude F, right? So this, if I consider one charged particle over here, this charged particle will experience a force due to the remaining 7 charged particles, right? And he's saying that assume that net force to be equal to F. Now, if these charges were placed on the vertices of another cube whose edge length is B, so we now need to calculate what would be the net force acting in that case on one of those charged particles, right? Okay, so it's a pretty interesting question, one which requires a slightly different way of going about it. Okay, but let's start going about this question, right? So we realize that if I consider any charge Q over here, for example, let me consider this charge Q. There are 7 forces acting on it due to the 7-point charges. Let me start listing down those forces and their values. So the force due to this Q on this Q will be in this direction. And the value of that force will be equal to KQ by A squared. Right. Similarly, I'll have a force due to this Q on this, and that force will be acting in this direction, and that will be equal to KQ by A squared. Right. Let me take now a force which is maybe from the body diagonal. So that force will be equal to, if I have to write the exact value, that will be kind of in this direction. And the value of that force will be equal to KQ, sorry, all of these are squares. So KQ squared by 3A squared. Right. So I could list down all the 7 forces and then try to calculate what your net force over here will be equal to. But that will be a lengthy process. And here, if you notice, we don't need to get the exact expression. We just need to relate it to the next case, right? So a better idea over here, or a smarter idea over here, would be to say that the net force acting on this. So in this case, the net force acting on this is given as F, is the sum of all these forces. And if I add up all these forces, I see that K, Q squared and A squared are common. So, you'll just get something in the form of a constant into Q squared by A squared. Is what we need to realize in this question over here, right? So in this case, your force expression, I can say roughly is equal to beta into Q squared by A squared. Now, if your charges were placed on the vertices of a cube of edge length B, then what will our new force expression be equal to? Our new force expression in that case will also have a similar form, but now the proportionality constant will remain the same. Your charge is also the same over here, it will be equal to Q squared only. But now instead of your edge length being A, your edge length now is equal to B. So our new force expression will be in the form of beta into Q squared by B squared. So now it's just a matter of comparing this new force with this old force. So what will my new force divided by old force be equal to? So beta gets cancelled, Q squared gets cancelled. The only thing we're left with over here is we'll have only A squared divided by B squared. So from this, we'll get a new force expression to be equal to F into A squared by B squared, right? So a question which seems pretty lengthy in first glance, like you might have to, or at least the brute force approach over here would be to assume that we'll have to calculate the force to all the 7 charges. But making use of proportionality will greatly simplify this question. And hopefully this question proved useful to your understanding. See you guys again in the next question.